forming light into electricity. Everything is there to draw in light, from the camera's buttons, controls, and dials down to the lenses. What the digital camera does with light is what makes it so revolutionary. It turns light into electrical charges that become the image captured on the screen. So how does that work? Let's break it down and zoom in on the parts that make it all happen. Every single piece of the camera is there to help capture the best image. But first, there needs to be light. To take a photograph, the #1 requirement is a light source. Light particles, or photons, leave the source, bounce off a subject, and enter the camera through a series of lenses. The photons then follow a designated path on their way from photon to photo. A series of lenses allows the photographer to capture the clearest image possible. This lens diaphragm is what controls the amount of light that the photographer allows in through the camera's opening or aperture. After crossing the diaphragm, the lenses, and entering the aperture, the light bounces off a mirror and heads for the viewfinder. Before it gets there, the light is flipped over as it passes through a prism. That's so the image seen in the viewfinder is right side up. If the photographer likes the image, time to press the shutter button. The mirror lifts and the light rushes in. For a fraction of a second, the light is not heading in the direction of the viewfinder, but for the very heart of the digital camera, the image sensor. The duration of this fraction of a second depends on the shutter. That opens just long enough to expose the sensor to light. The exposure can be as short as 1/4000th of a second. That means in the blink of an eye, the shutter can open and close an incredible 1400 times. How? It takes 2 curtains. When the first one opens, the second one closes. So only a tiny amount of light squeezes through. Now, to the real heart of this digital revolution. The element that captures the image. The image sensor. A tightly structured grid made up of extremely tiny light sensors. So tiny, each one measures just 6 microns wide. That's 6/millionth of a meter. More than 5,000 of them could fit on the tip of a sharp pencil. But first the light must pass through something called a Bayer filter. That separates it into 3 colors: green, red, and blue. Because each light sensor can process only a single color, when the photons hit the light sensor, they are absorbed by the semiconductor material it's made of. For each photon absorbed, the light sensor emits an electric particle called an electron. The photon's energy transfers to the electron. That's the electrical charge. The brighter the image, the stronger the electrical charge is. So each electrical charge has a different intensity. A circuit board then converts the different intensities into computer language, digital bits and bytes, or a series of ones and zeros. They represent millions of tiny colored dots that make up a photo. The pixels. The more pixels in a picture, the better the resolution. This camera has a resolution of 3,872 pixels by 2,592 pixels. That's about 10 million pixels, or 10 megapixels. That means 10 million microscopic light traps, working with all the other camera's components toward a single objective, turning light into electricity to make taking pictures a real snap.